So, let's get started. Independent samples. One of the professors in the BYU Idaho math department collected data from BYU Idaho students to compare the mean wages of BYU Idaho male students to BYU Idaho female students. The students from his classes completed a survey, which he then used to analyze if there is a difference in these wages. So what is the research question? Let's see, I think it is what is the difference between male and female wages at BYU Idaho? What do you think?
Yeah, I'd agree.
Okay.
And then null hypothesis.
So the null hypothesis would be that the first group is equal to the second group?
Yeah. I was trying to think of what is it, like the mean the mean of group 1 and the mean of group 2. And then I would say that the alternative is that the mean of group 1 is not equal to the mean of group 2.
Okay. Collect the data. Describe the data collection procedure. Yeah. Oh.
The students from his class completed a survey which he then used to analyze if there is a difference in these wages.
Veronica, her mic isn't working, so that's
Okay.
why
Veronica, if you can still hear, can you wave your hand if you can still hear me? Yes. Okay, that's not your hand, that's your head, but okay, I got you. So go to the top, and it might be that your mic is muted. No? Oh, well, I tried. Um, hmm.
Are your headphones plugged in? Sometimes that makes
That's what happened to me before. Well, actually, I mean, that would mean she wouldn't be able to hear us. So, yeah, that wouldn't really affect it, I would think.
No, it doesn't really, but there's one time. It's just weird sometimes, so I was just asking. I don't know. Okay. So she can hear. Okay, cool. So Veronica, just type when you have something to say. Very good. Okay.
I could just call her, and no.
That's good. So do you have a group chat thing open, Clayton? Can you see that?
Group chat? Yeah, I see it. I mean,
See where she's been
it'll
messaging?
probably be slow.
Okay. Either way, it doesn't matter. So, all right. So, describe the data collection procedure. So, see, his surveys, right? He took
Yeah, that's
surveys.
what I was saying earlier.
Oh, sorry, I didn't hear you. I was worried about Veronica.
So Veronica, you can call me, or I mean Kevin. It doesn't really matter. Yeah. Either way, we'll just put you on speaker. Evidently, there's a turkey on the other line.
What on earth? That was weird. Alrighty.
What is that? Oh, call ended.
Yeah.
You should probably call Kevin this time, and if that doesn't work, we'll just move on.
That's funny.
Water real quick.
Hello. Hello.
Hello?
Yeah.
Okay.
I
I
think
don't know what that was.
that was weird. Yeah.
Yeah, it's even weirder now. Can you hear myself?
Yeah. I'm sure that is weird. Okay. Cool. So. Um.
Yeah, that's good. You guys?
Okay. Sounds good. Hopefully you can get back your audio. Maybe.
Okay.
That was weird. It was all echoey. All right. Cool. So describe the data in a short paragraph. Use summary statistics to describe the data. After the paragraph, insert an appropriate and well-labeled graph to illustrate the data.
Okay, so I've already done that.
Okay.
So
Did you just include like the mean and stuff? And
yeah, it's usually n, the mean, and standard deviation.
okay, let me get that stuff. So I have this class survey. From which column do I take stuff? Confused.
So basically, you're looking at the wages. Let me see if I can.
Oh, wage. Okay.
Let me screen share. It should already be highlighted when you pull it up.
Oh, it may have been, but I didn't
Okay,
notice.
so under N, you go to wages, and then if you look on the left, it'll be female. This is what you would put. I'm guessing you would put in the group 2 because the males were already highlighted in group 1, but it doesn't really matter. In this lesson, it can either be a negative or a positive, depending on which which group you put in. You know what I mean. So yeah, you'd highlight the females first. You stop right there to the males, and then you would drag it down all the way. Yeah.
And then you put in quantitative inference
Mm-hmm.
under variables 1 and 2. Contents. Paste. Oops. Paste. Goodness gracious. Let's try this again. Hang on a second, sorry. Copy. Okay. You're okay. No worries, mate. Okay, the males. Copy. Alrighty. So the mean. Quite interesting. So
What'd you get?
let's do. Hang on. Actually, so it's 20. So for variable 1, I got the mean is 9.759. Variable 2, I got 11.935. And then, yeah. And standard deviation's 3.169. Is this the same as you got?
Yeah, I mean the variables are mixed up, but as I said, it doesn't matter in this specific test if it's negative or positive or which way it is, you know.
Hmm.
So yeah, I mean 11.9535 and 9.759 for the mean.
Okay.
I have
How do you,
85 and 91 for the number, and I have 10.491 and 3.3 or 3.169 for a standard deviation.
okay, I'm sorry. Say that one more time.
So
You
for
have
variable
169.
one, huh?
Do you have so let me see. I want to make sure with the males. So do you have 85 as N?
Yes.
Okay, and then 11.935 is the mean. 10.491 is the standard deviation, and 1.138 is the standard error of the mean.
What did you say for the standard deviation?
10.491.
Okay, that's right.
Sweet. Okay. And then a graph. It would be a histogram like we did in the other.
Oh, so Veronica, you got 88. I again, you know, pulling up the answer key and all that. Oh no, actually you're right. It is 88. But I wonder how we both got to where it's 85. But
Huh. Oh, I know why. In mine, 3 of the numbers are missing. I don't know
we
where they are, but it's in the original document too.
let me take a look. Well, the missing numbers, um, those are like I'm guessing for people who do not work. Let me.
True. So, Veronica, what did you get for? What did you get for? Let's see. Did you get all the same means and standard deviations and stuff, Veronica? So I'm
So
guessing.
so from what I'm looking for wages, I put in all the data. There's nothing missing. So I mean, this must be another one of his mistakes, or whoever made this. I don't know. I mean, but that's pretty much what it says. Because I mean,
So
for females, it's 95, and what I got is 91. But all the variables are there.
Uh, if you look, so they're actually not all there. Like you had to put in zeros for them or something.
Oh, maybe. Oh, yeah.
Because
That might
there's
be why.
with the females, there are some blank spots, and for the males. So I'm
No,
guessing
that's true. I mean, I knew about the blank spots, and those blank spots are just a sec.
So, Veronica, for the mean, tell me, and shake your, or nod your head if you got the same thing. So for the females, the mean was 9.348. Yeah? Hmm? Okay. Hmm.
Oh, sorry. You want me to try this. Okay, let me go ahead and finish up inputting this just to make sure. I'm pretty sure it's going to be okay. Yeah, I got what the answer key says.
Oh, yeah, what is the, let me see. Oh, answer key.
Hmm.
Uh, huh. Crud. So, okay, wait a minute. So Clayton,
Mhm.
you did get the same thing as the answer key?
Yeah, because inputting all the zeros. I mean, basically, what I was thinking is it doesn't affect the data because that's all people who do not work. But as you said, you have to put in zeros to make sure that counts. I mean, they count.
Huh. I'm getting a different answer. I'm not sure why.
What is it?
So for the for the females, it says the standard deviation. Hang on a second. Ah, never mind. I'll worry about that in a second. So for the females, it says the standard deviation is 10.49, and I got. No, I'm sorry. For the standard deviation, it says 3.169. I got 3.674 in my thing. Hello? Still there? So, what do you think?
I mean, I think it's the answers that um I mean I got, of course. I mean, because I mean all don't I mean you got the same thing as me, but all
I
I did,
know.
I mean, that was different is I put zeros in those blanks, and made that made N 88 and 95.
Yeah, but look at the standard deviation now. In the answer key. What is the does it, in your answer key does it show the mean?
Um, it does show the mean, and let's see. Yeah, the mean is a bit different. He he definitely made a mistake in this area.
Yeah, I agree. That's dumb.
I mean, like Well, it could be that he did not put the zeros in there. I mean, and he just counted the actual um, number. And that's probably how you should do it, and that's also something we have to watch out for ourselves. So,
All right, cool.
yeah, so just delete all the zeros, leave the space open, but just know it's 88 and 95. And then when we do our homework, we need to count the numbers ourselves.
Okay. Sounds good.
Okay. Okay, so that was, I guess it was worth the wait. I mean, could have saved us the trouble for one answer. Okay, so what type of hypothesis test is appropriate? The independent samples hypothesis test, because it's because it's male and female. Is that what you guys think?
Yeah, I agree. Yep.
Okay, are the requirements for this test, are the requirements met for this test? Explain.
Well, there was a simple random sample from both populations. Or no, because it was a survey, right?
Yeah.
So it's
So
different?
yeah, because, I mean, there's no random sample taken from that, and
Oh, wait a minute. Oh. Yeah, because I guess the sample would just be the students in his classes, and the population would be BYU Idaho students in general, right?
yeah, I guess. I mean, I have to reread it, but I mean, it's not asking that, so I won't. Um, and it says right here the sample size is large enough for each sample, so we can assume normality. So that's something we also have to look at.
So the requirements aren't met for this test. Oh, okay. Okay. Well, one requirement's met, but the other one's not met, right? Because it's not a simple random sample.
Huh?
'Cause it's not a. There was no simple random sample,
Yeah.
so that's one of the requirements, isn't it?
I don't know if it is, or I mean, if it has to be, or it can't be. Um,
I don't know. I was thinking that the requirements were met, even though it's not like a traditional simple random sample. It still is a sample. I don't know though.
oh, okay, that's why I don't have the lesson open. Um, Let me. Um,
What do you mean, Veronica? Oh. It's not a simple random sample because it's independent. Hmm. I don't know if it has to be.
so I'm looking at the lesson now, and it says there are two requirements that need to be checked when conducting a hypothesis test for two means with independent samples. Simple random sample was drawn from each of the populations, and the mean is normally distributed for each group. Remember, the second requirement will satisfy if original populations are normally distributed or if the sample sizes are large.
Hmm.
So one of them is not met, I guess.
So the sample sizes are large, so we don't have to worry about that. But I keep thinking Veronica is trying to say something. Um, but let's see.
Well, it's not asking us.
Oh wait, what does the answer key say?
I already said
Oh,
the sample size is large enough for each sample so we can assume normality. It was not a simple random sample.
right. Okay, cool. then we were right.
Mhm.
Voila.
Explain if it is met, but I guess we pretty much said ourselves it does not. I mean that the requirements are not.
Yeah, okay, sure.
Okay, hello?
Hello. Did it do it?
I
Did
can
it
hear you. Did you put me on speaker?
Yeah, I did. Does that work? Can you hear me?
I can hear you.
Okay, I'll try and put it next to the computer so when he talks you can hear him. Can you hear me still?
Yeah.
And I can hear her.
You can hear her?
Okay, fair enough.
I
Yeah.
can hear her.
Sweet, it works great. Okay, cool. This is very inventive, I think. So great job. Sorry. It's been an
It's too
interesting
hard
day.
to type fast.
Yeah, very, very critically thinking. Okay, cool. So, sorry. I'm sorry. So, for C, compute the test statistic. So I feel like everything's going to be wrong on Excel.
So I got from that 1.836, and that's a positive.
Yeah, it says in the answer key plus or minus
Mhm.
1.836. So
Because it depends on which group you put it into, which variable. I mean, because it's, it's minus 1, I believe. It could be the other way around. I don't know. State the degrees of freedom. Oh, crap. The degree of freedom on mine is 98.263, and that's what the answer key says. Compute the p-value and compare it to the alpha level, and the p-value I got is 0.069. And the same with the answer key. So we refuse to reject the null hypothesis because it's higher than the significant level
very
or
good.
level of significance. Present your conclusions in the form of an English statement.
Dang it, I was hoping we could do German.
I was thinking of
Just kidding.
a British accent, but
Yeah, the Queen's
what-
English. Okay, cool. Sorry. It's been a weird day and I'm in a funny mood, so.
yeah.
All right, so present your conclusions in the form of an English statement. I would say the English statement would be that, see, we failed to reject the null hypothesis, so that means that the wages are roughly, the mean of the wages are the same, male to female, right?
No, I wouldn't say that.
Because the null hypothesis was,
Well, G says we have significant evidence to say that there is a difference between wages of male and female BYU Idaho students. We already know the means, and they're different.
yeah, they are very
But-
different. That's what I was thinking.
But I mean, so I wouldn't put it in that statement. But I mean, basically the way it's said in G.
Well, isn't the null hypothesis that the mean of the first group is equal to the mean of the second group, or is that a different? Am I mistaken there?
I'm sorry. What was your question?
So, look at 1B of this worksheet of the part 2, and we wrote right that the null. Maybe I'm wrong, but we wrote the null hypothesis is that the population mean group 2.
No, one of us is cutting out.
So I wrote that the mean of group 1 is equal to the mean of group 2 for the null hypothesis. Is that correct?
Yeah, that's what we start out with, because basically we look at, we look at the mean of group 1 minus the mean of group 2 equals 0, and to basically add group 2 to the other side, so it's the mean of group 1 equals the mean of group 2. So yeah, that is the null. And then the alternative is basically that he wants to see if it's different.
Right. So, but we ended up failing to reject the null hypothesis, right?
Oh yeah. So I guess
The p-value.
that is. But I
Is
don't
the
entirely.
p-value higher? If the p-value is higher, we do fail to reject it, right? Or
Yeah. No, I get what you're saying. I mean, I don't entirely get. I mean, we have the mean for both of them. I mean, men's was higher, or I believe it was men.
I just
so-
had a thought. Maybe because the mean for these two samples is different, because the sample size is different. So you're like dividing it by a bigger number for the bigger group when you do the mean. But like we can conclude from our hypothesis test that overall the population, it is similar. That the means are the same. Is that what we're concluding for our hypothesis test? Because we could, if the group sizes were the same, we could easily say, oh,
But they're not the same.
right. But yeah, you're right. They're not the same.
So we wouldn't be able to conclude that because they're not the same. Like they're not equal.
Yeah, they're not equal. So we
Well,
have to find out through a hypothesis test, with the p-value and the level of significance, the whole, spiel. That's why we have to do that, because if we can't look at the means just by themselves because the sample size is different, right? Am I on the right track here, or am I completely off base?
I think so. No, I think that makes sense. I think it would have to be the same sample size for us to be able
Yeah.
to conclude that the wages are the same. If it's not, we can't really conclude anything because the sample size is not the same for each gender.
Right. And then, like, for example, the females, you got a bigger sample size, like 95, and you're going to be dividing by 95 at the end, and that's going to give you a smaller number than dividing by 88. So that's what I think.
I got you.
Okay,
Yeah.
cool. So that's why we have to do a hypothesis test, and that's why I think we can conclude that the means are the same for the whole population.
Yeah.
Okay, cool. That's our English statement.
Well, basically, I mean, as I said, in the answer key, it says we have insufficient evidence to say that there is a difference between wages of male and female BYU Idaho students. So you mean we still have inefficient? I mean,
that makes sense. That makes a lot of sense, because we're not saying that they're the same, but we are saying that we can't say they're different.
Yeah, and I mean, I can't remember which lesson we learned that in, but that's what we've always gone with when we rejected the null hypothesis. I believe because, eventually something could come along that proves something better. Prove the null hypothesis wrong.
Sure.
Okay, so let's see. Rather than testing a hypothesis, now say you just wanted to estimate the difference between male and female wages at 95% confidence level, create a confidence interval to estimate this difference. So I got -0.176 and 4.529.
Yeah.
I think ours is different, but I think it's something we had to done wrong.
Yeah, something messed up my Excel spreadsheet, so, but I think, yeah, that's why I seen the answer key, so I think that's right. I
Well,
kind of, but,
what'd you get?
so my Excel spreadsheet got something totally different, and I think that's because of something that went wrong somehow.
Well, if it's like a difference in positive and negative, I mean, it's as I've been saying, basically all that is if you put group 1 into group variable 1 and group 2 into variable 2, or the vice versa, like that can actually make it a positive or the difference between a positive and negative. The number's the same, but I mean that's the difference. Because there's nothing that's I mean this is not post and pre. This is just comparing two different groups. So it's not a wrong answer if it's negative or positive.
True. Okay, cool. Cool. Alrighty, let's.
So now interpret the confidence level you have built above.
Okay, the answer key says we can also see that there is an insufficient evidence using the confidence interval method because it's 0 is included in our confidence interval. Huh, I wasn't aware of that. That's interesting.
I'm guessing that means like because like it's within. I mean 0 is within those two. I mean a positive, negative, and all that. You know. But if like say they were both positive, like one was 1. I mean one answer was 2 and the other was 4. I mean 0 would not be in between those two.
It's true.
Okay. So take action. I don't know exactly why he wanted to try to figure this out. I mean, do this. Yeah, it looks like he just wanted to analyze it for the heck of it.
Wait,
So,
what's the question?
take action. Number 5 is take action. In a short paragraph, describe the action you feel should be taken based on the statistical results above. There's no real action that needs to be taken because, I mean, he pretty much just did this for the heck of it. I mean, there's nothing that says there's nothing that says he wanted to do something like he was testing it out for this reason. If it was like, for example, like in the lesson where they were comparing if there was a difference in the care in each different program or something like that, there was no difference. So the action they took was it's better just to choose the cheaper one. We can't really say anything for this because there's no real problem.
Well, couldn't we change the way we did?
Huh?
The way they did the experiment?
Yeah, they could.
Be changing the way they did it to make it more accurate?
Yeah, they could. I think the next step would probably be to, yeah, narrow the test or take or I don't know, do another, maybe increase or decrease the significance level and try and see if they can get it so that so that we can either reject. So I think so that we can reject the null hypothesis eventually, or keep it, or we could probably do a test where we can figure out if we should keep it. I don't know.
All right. So I think we're ready for the quiz. I mean, it took a while, but we know what to look out for. Okay, starting.
Are you ready to start the test?
Yes.
Okay, so a total of 14 questions we have to answer.
Okay.
What are the So number th oh, are you guys both on there?
I'm not quite there yet. Just hold on.
Yeah.
Wait, maybe I am though. Actually, no, I'm not. So there.
I just saw it.
What was that, Veronica?
No, the answer to that one, I had just seen it.
Okie doke. What requirements must be checked when conducting a hypothesis test comparing two means independent samples?
Is this the first one?
This is the third one. Or, yeah, number 3. Yes. Are you with us, Veronica? Sorry, I didn't check to see if you were with us.
Yeah.
You're with us? Okay.
Uh-huh.
Do you see what question we're on?
You're on number 3?
Yeah, number 3. What does it say for you? Does it say something different?
Huh?
Does it say something different for you?
No, it's fine.
Oh, okay, cool.
Yeah, you're fine.
So I'm pretty sure the answer is A and B.
That's what I put.
Yeah. So for the test statistic
Oh, that's
for...
what I said. I thought the first one was right.
Yeah, the first one is right too. And the second one is also right.
Okay.
So that's why it's A and B. So the test statistic for a hypothesis test was comparing two means with independent values. I'm sorry. The test statistic for a hypothesis test comparing two means with independent samples is a t-score.
Yeah.
Two samples are independent if knowing which subjects will be in group 1 determines which subjects will be in group 2. I think that's wrong. I think it's the other one. Knowing which subjects are in group 1 tells you nothing about which subjects will be in group 2. That's the definition of independent.
Yep. Okay.
Very good.
Alright, here we go. Let's see how this one goes.
All right, cool. Oh, great. I should have...
Wait, so just to make sure on the quantitative interference procedure, are we putting it in the two-sample t-test or the three-sample t-test?
The two... Say the first... Say both of those again. Are you asking if you could put it in the paired sample t-test or the two-sample t-test?
Yes.
I'm pretty sure it's the two-sample t-test.
Okay. Wanted to make sure I was doing it right.
Yeah, yeah. Is that right, Clayton?
Yeah.
Okay.
The two sample t-test.
Okay. Is this one? Okay, never mind. It's gonna take a second for me to get the data on there.
Okay.
Because I gotta copy and paste it. And yeah. Whatever, I'll just do it. I'll just type them in. Easier for me. Yeah.
Okay.
Oh. Okay, it'll still take just a sec, so hang on.
Oh, all right.
So group 1.
Okay. This one is better because it looks like they're normal.
I think yes, Dan.
The test is greater than right?
I don't know yet. Hang on. I'm not sure. Okay. Okay.
Almost got it.
Not quite. It's going to take. Sorry, I decided to copy and paste it to my email after all because I think that would be faster instead of typing each individual number out. Because I'm working with another computer.
That you're
and the other-
working on? I mean, doing or what are you trying?
I'm working on. Yeah, that's what I'm doing. I'm copying and pasting right now.
Oh, okay. Well, I have 6 through 11. I don't want to
Oh, great.
go too far.
Good. I was trying to.
You know when you're ready.
Compose.
So, for the type of test, are we doing greater than?
What's up?
It's I'm not sure yet. Clayton, is the type of test a greater than test or not equal to test or less than?
It says it at the top of 6. I believe that's less than.
Thank you.
What? What did he say?
He said he believes it's less than. Is that what you got, Veronica?
Yeah.
That it's less than?
Okay. Sorry.
Wait, what?
Nothing. Yeah. Oops. Okay, cool. So, it's the quiz. Sorry, Clayton, I know you're ahead. but we know the degree. Just make sure, just verify my answer, Clayton, okay? So I got for the degrees of freedom, 37.996.
Yeah.
Yeah.
So I have listed not equal to. Does that doesn't make a difference?
It makes a difference for the p-value.
Oh, for different values. Oh, okay, here we go.
Yeah.
Less than.
So for number 7, I got 288.597. Oh, wait, no, I'm sorry. I meant 206.637.
That's what I got for 7.
List 2. Oh, okay. Sorry. So I'm just gonna repeat it. So 288.597. Oh,
No,
you
no,
got?
no. Sorry, I said that was the mean. Sorry, I meant
Oh.
sorry. Was 206.637.
Okay. Cool.
Sorry. And then, are you guys ready to go to 8?
Yeah.
For 8, I got -0.434.
Yep. Me too. For the p-value, I got 333.
That's what I got.
What is the correct decision based on this evidence? P-value is. What's the level of significance? Sorry.
We failed to reject it, right?
The p-value. Yeah, we failed to reject it. Yeah. Because the
And then
p-value is greater, so we failed to reject it, right? Okay.
And then 11, I still failed to reject it.
Yeah, still failed to reject it. So for questions 12 through 16, paste the values listed here into software, quantitative inference procedures, blah, blah, blah. And the 2-sample test, okay, blah, blah, blah. First data set represents the number of times freshman students from Utah cooked their own dinner in a month. The second data set represents the number of times freshman students from Colorado cooked their own dinner in a month. You suspect that the freshmen from Utah cooked dinner for themselves a different number of times than the freshmen from Colorado. The null hypothesis is that uses level of significance 0.05. So
They're different.
sorry, what'd you say?
Nothing. So for this one,
What is the appropriate alternative hypothesis? Oh, let me see. I know the answer-ish. I just gotta concentrate on this for a second, then I can.
they're not equal to each other.
That's true, but I think one of them is greater than the other.
So basically it says the first set represents the number of times freshmen from Utah cook their own dinner in a month. Oh, sorry, this in the... you suspect that freshmen from Utah cook dinner for themselves a different number of times than freshmen from Colorado. Okay, so yeah, I misread it. It's different.
So what? So that means what exactly? Sorry. What do you conclude from that?
So basically, it says it in the sentence. You suspect that freshmen from Utah cook dinner for themselves a different number of times.
Oh, so it is not equal to. So it's not. It's just not equal to. It's not.
Yeah, it's not equal to because I mean, whenever they use different for the most part, it's not equal to. I mean, I mean, they'll probably say that it's more than or less than or greater or whatever. You know, so yeah, I mean, it's not equal to. For T, I got 0.8, 0.845.
Mm-hmm. And I got the p-value at 0.411.
I'm sorry, guys. What did you say for the t value?
0.845.
Okay, just Clayton say it because I couldn't understand.
0.845.
0.845.
Wait, I didn't get that.
What'd you get?
Wait, are we going for the t-value or the p-value?
The T value.
T.
He was asking for the T value. Huh?
Are you talking about number 13 or number 14? I can't tell the difference between.
I'm talking about 13. 13, and we're talking about the T value.
4, 5. I was talking about 14, sorry.
Huh. Because I got. Let me see if. Let me just.
Don't forget to change the type of test to not equal to.
Yeah, I got that. Let's see. Okay. I figured out what I did wrong. It was just formatted weird. So I got 0.845. Is that right?
Yeah.
Because I accidentally copied a space after one of the numbers, so that messed it up. So, okay, what is the p-value? 0.411.
Yes.
What decision do you make? Let's see.
We still have to reject.
You still fail to reject. How original. I'm just kidding. Okay, give the 95% confidence interval. That means negative 2.241.
Make sure it's negative 2.214 because.
Yeah, sorry.
And then 5.147.
Sweet. All right, cool.
Okay, submitting now. And I got 100.
Sweet, 100%.
Did you guys want to do the homework now after we do the group collaboration and all that?
Yeah, sounds good. Do you want to do that, Veronica?
Huh?
Do you want to do the homework too? Homework?
Yes. Could we start a new thing to see if maybe it'll work if we do a new chat thing?
Yeah, let's just do a normal video call. So I'm just going to exit out of this call, and then...
Let's do the group collaboration first.
Exactly, that's what I was thinking, yeah.
And Veronica, I didn't see